Okay, these next two I think are some of the more challenging ones. The math itself isn't hard. The hard part is being able to write an expression for these angles and then put that into an equation. So I'm going to walk you through that because that's going to be a little bit tricky. And then once I show you, then you'll be able to kind of understand how to go about setting this up. Okay, first we have to know some facts or some definitions. Okay, two angles are complementary. What we know about complementary is their measures sum to 90 degrees, or they add up to 90 degrees. Okay, so that's important. Then we have this guy. One angle measures 26 degrees more than twice the other. Okay, so that's kind of weird. We want to find the measure of both. So this is what I'm going to do. I'm going to just talk about these angles. There's two of them. I'm going to talk about angle 1 and angle 2. Okay, I don't know what either of them are, but I know there's two of them, and I know they have to add to 100, or I have to add to 90, excuse me. Okay, so let's call the first one x. Angle 1 we're going to call x. Okay, just because we don't know what it's called, it's a variable, so we just make a variable for it. Now we could call this one y, but that's not going to help us solve it. We actually want to write an expression that uses x's if we can. So this one's x, and we know the relationship is that one angle measures 26 degrees more than twice the other. So this one we can say is 26 degrees more than twice this one. Okay, so more than, that means add 2 to something. 26 degrees more than. So I need to add 26 to something, but more than what? What am I adding 26 to? Twice the other one. Twice means times 2. Sorry, 26. 26 degrees more than. Sorry, that's add 26, not add 2. Add 26. Add 26. And then twice the other one means multiply by 2 times 2. So what we need is 2 times x plus 26. This is 26 degrees more than twice the other one. Okay, so those are our two angles. So this is kind of the hard part, right? The first thing we have to do is come up with the measurement of the two angles. The first one's easy, right? Measure of angle 1 is just a variable, measure of angle 2. Okay, now that we have these two expressions, we can put them together in an equation. So what we know is the measure of angle 1 and the measure of angle 2 is 90. So the measure of angle 1, which is x, plus the measure of angle 2, which is 2x plus 26, has to equal 90. Okay, so here is angle 1, or the measure of angle 1, and here is the measure of angle 2. Okay, now we've got ourselves an equation that we can solve because we can combine like terms. So 3x plus 26 equals 90. Okay, subtract 26 from both sides. So 3x is equal to, looks like it's going to be 64, and divide both sides by 3, and we're going to get x equals, I'm pretty sure this comes out not good again. So let's do that. So 64 divided by 3. Okay, so that's, you know, that we could write that 21 1/3. We could round. If we round, we're going to be a little bit off. But I think that's kind of the easier way to go. So remember, these are supposed to be complementary. They're supposed to add up to 90 degrees. So this is not the angle that we want. This is just x. We want to find the measure of both angles. Okay, so to get the first angle, actually, this is one of the angles, right? Because x was the measure of one of the angles. So when we find x, that's part of our answer. It's not our full answer. The other angle that we want is going to be 2 times 21.33 plus 26. That's going to give us our second angle. So let's take this guy here, and let's multiply by 2, and then let's add 26. So that's 68.67-ish. So this is one of the angles we were after, and this is the other angle we were after. Are they complementary? It looks like if you added them together, you'd get 90. So let's add this to, just to double check, 21.3333333333. There you go, complementary. Okay. All right, two angles are supplementary. Okay, well we know that means their measures sum to 180 degrees. So that's the fact that we need. Okay, one angle measures 16 degrees less than 6 times the other. Find the measure of both. Okay, so that's, again, that's kind of rough. We know they add to 180, but that's kind of confusing. So let's just start with the measure of angle 1 we're going to call x. The measure of angle 2, we want to write some expression in terms of x, or using an x. So one angle measures 16 degrees less than 6 times the other. Okay, 16 degrees less means minus 16 from something, right? Less than. It's got to be minus from something. We're taking it away from something. What are we taking it away from? 6 times the other angle. 6x. Okay, so 16 degrees less than, that's the key word than, it has to go behind the other thing. We've got to subtract it from 6x. Okay, so those are the two angles. Now this is the tricky part, this is the hardest part right here, is getting that second angle, angle 2. But we know that if we do x plus 6x minus 16, we better get 180 degrees, because these angles are supplementary. So this right here is the measure of angle 1, and this right here is the measure of angle 2, and we know we have to add those together to get 180 degrees. So when we combine like terms, we get 7x minus 16 equals 180. All right, 7x there. So let's add 16 to both sides. So 7x equals 196. Okay. We need to divide both sides by 7. Don't mind the picture of my wife. So 196 divided by 7 equals 28. Okay, so x equals 28. All right, now that's not what we were looking for. That is just x, right? So what we're looking for is measures of both angles. So measure of angle 1 was x. That's part of what we need. So 28 degrees was one of them. And then the other one is going to be 6 times 28 minus 16. So let's take that 28. We're going to multiply it by 6. And then we're going to subtract 16. 152 is the other one. Now those should be supplementary. They should add up to 180. So if I take 152, which is one of my measures, and I add it to 28, this is just a check right now. These are the two angles for our answer. But just to check, let's add 28. Okay, cool, they come out to 180, so these are definitely supplementary. Okay, those are the measures of the two angles. All right, let's take a look at the last few on this one. We'll just go ahead and finish this one out. This is a little bit farther than we went in the video, but that's okay. We'll just keep on going, and then we'll tackle the next page. Okay, so this is one of the segment things that we had. So find the value of MP. So we want to find, when we see the two letters next to each other and they don't have like a line above it, what that means is the measurement of MP. So we want to find out what this measurement is equal to. Now if we had a line above it, that would be like a segment, but we don't want a segment, we want a measurement. So no line above the letters means measurement. Okay, so find the value of MP if MP equals 3x plus 3. Okay, well that represents the measurement, but we want an actual number. We don't want to have an x there. We want to have an actual measurement. Okay, Pn equals 5x. So the measure of between P and N is 5x. And then the measure of this segment, Mn, is 43. Okay, the segment addition postulate is the idea we're going to use here. Okay, so again, the instructions for this section were use theorems, postulates, definitions, right, to set up and solve equations. So that the segment addition postulate says that if P is between M and N, then MP plus Pn equals Mn. So what we know is this little segment measurement plus this segment measurement equals the big one. So 3x plus 3, the little guy, plus 5x, the medium guy, has to equal the whole segment. So combine like terms, you got the 8x plus 3 equals 43. Okay. We're going to subtract 3 from both sides. 8x equals 40. Divide both sides by 8. And x equals 5. Okay, not what we were looking for, but that's part of what we need. We wanted the value of MP. And MP is 3x plus 3. So the measurement of segment MP is 3 times x, which is 5 we know, plus 3. So 15 plus 3, or 18 units. We're talking units, or measurement, since we don't know if we're talking centimeters or inches or feet or whatever. We'll just say units. Okay, so that's how you solve the segment problem. Okay, let's look at 34 and 35. So hopefully what you're seeing by now is you're recognizing that these two guys are vertical angles, right? You have these two straight lines intersecting each other, and these are like opposite, kind of on the other side as each other. These two are vertical angles, and therefore they are congruent by the vertical angles congruence theorem. And if they're congruent, that means our measures are the same. And so what we can do is we can say the 148 is equal to 3x plus 1. So it's not a proof per se, but we're using a lot of similar deductive reasoning to get to this equation, right? These are vertical angles. How do we know that? Definition of vertical angles. Therefore, they must be congruent. How do we know that? Because of the vertical angles congruence theorem that we proved. Okay, what does congruent mean? That means their measures are equal by the definition of congruence. So it's almost like a 3-line proof, and this would be the 4th line. Therefore, 148 equals 3x plus 1. So that's all the chain of reasoning that you're not really seeing, but that you should be going through in your mind. Now from here, we can start using some other stuff, like we can minus 1 from both sides. What's the justification for doing that? It would be the subtraction property of equality. Okay? Then we got to divide both sides by 3. What's the justification for doing that? Division property of equality, and x equals 49. Okay? Now that's what we were after, right? Find the value of x. Okay? Check. 49 degrees. But let's just double check, right? If this is 148, this should also be 148. So if I do 3x plus 1, that would be 3 times 49, which we know is 147, plus 1, which would give us 148. So that checks out. If we plug it back in, we get 148, which is what we wanted. Okay? So vertical angles congruence theorem. Okay, same thing here. So let's go through that chain of reasoning again. We know these are vertical angles. How do we know that? Well, the definition of vertical angles, basically. These are two angles whose sides form two pairs of opposite rays. Therefore, by definition of what vertical angles are, they must be vertical angles. Okay. What do we know about vertical angles? We know that they're congruent. And how do we know that? Vertical angles congruence theorem. Okay, if two angles are congruent, what does that mean? It means their measures are equal by the definition of congruence. That's what congruent angles means. So we can set this up. Not a proof, but definitely following some reasoning here. Okay, so we can subtract 3 from both sides. And again, our justification for being able to do that is the subtraction property of equality. And we can divide both sides by 5. Our justification for doing that is the division property of equality. And we get 19 equals W, which is what we wanted. Okay, so just to double check, if I plug this in here, 5 times 19, that would be 95. Add 3, that would give us a 98. And those would be congruent. Okay, so 19 degrees is equal to W. So know those facts, you got to know those theorems, otherwise you can't solve these problems. And we talked about, some of those definitions on the first page of this assignment, and then some of the theorems that we're using we proved last week. So all those things are going to be important for you to know where to get started here. So that is page 3. Oh, sorry, that's page 4, and that should help you get through some of these. The plan is we're going to have a Google meeting. Today is Thursday. We're going to try to do a Google Meet tomorrow, a Zoom meeting tomorrow on Friday, and we'll go through the rest of this packet, or as much of it as we can, and then if need be, I'll go through some more videos like this for you to finish it up. Before we stop here, let's just see what else we got. So we got some more algebra problems that we're going to use. These, notice, are a linear pair, so they add to 180. Then we got some of these multi-step problems. So we know that we got angle 1 and angle 4 and angle 5. So 1 and 4 are vertical angles, they're congruent. 1 and 5 form a linear pair, they add to 180. So that kind of stuff. You're going to have to use maybe multiple steps on those. Okay, then we have a algebra proof, which is basically just solve this equation, but justify your steps. And we kind of talked about that on the last page, right? We could use the addition property of equality. We could use the multiplication property of equality. We're going to use all those to be able to get this. Then we got some segment proofs. Now these are basically identical to the proofs that you had on some of your homework assignments. So if you have those homework assignments, you might be able to go back and look at them for some help. You also might just remember them and be able to go through it. So the idea is, hopefully after you've seen these a couple times, you can start kind of trying them on your own, see how far you can get, and then kind of double check with some things that you've seen before. Okay, an angle proof, which again is virtually identical to the one I gave you. The only difference is, I think when I gave you one on your homework, the angles were numbered, and this time they're not. So sometimes it's a little tricky using the angle names with letters, but it's otherwise it's the same proof. Okay, this is proving a case of the congruent supplements theorem. Now they don't say that these are supplementary, they don't say that these are supplementary, but we know they are because they form a linear pair. So we kind of start with linear pair and kind of go from there. Now what we want to do is we're trying to prove a case of the congruent supplements theorem. So if you're trying to prove this theorem, you're not allowed to use this proof in the theorem. Sorry, you're not allowed to use this theorem in the proof because this is what you're trying to prove, so that's circular. So we got to do it without using this. Okay, and the next one is, or the last one here is prove the vertical angles congruence theorem. Again, if I'm trying to prove this, I can't say, oh, well 4 has to be congruent to 5 because that's the vertical angles congruence theorem. Yeah, but that's what we're trying to prove. So you can't use the theorem you're trying to prove in the proof of the theorem you're trying to prove. That doesn't work. So you're going to have to do it using like angle addition. But what you do is you basically use linear pairs, right? These are supplementary, and you kind of go from there. So that's kind of just a heads up on the rest of this. You actually should probably be able to do it on your own because we've done so many of these already in homework assignments or something really similar. So give it a shot, see how much you can get through. I bet you could probably get through a lot of it, and then we can use our time in the meeting. You can kind of just be checking your answers. You already have gone through it. I think that will be a more effective learning strategy for you. So give it a shot, and I'll talk to you guys soon.